This video is a brief introduction to geometric sequences and series. Alright, now a geometric sequence has the form A the first term, A times a common ratio the second term, A times a common ratio squared third term, A times a common ratio to the power of 3 fourth term, and so on. And the nth term is A times a common ratio to the power of n minus 1. Okay, so for instance you could have a first term, say starting with 2. Okay, don't forget, with a sequence you place commas between them. With a series we place the addition sign between them, and that's the difference between a sequence and a series. Okay, we could have, let's say, a common ratio of 10, so this would be 2 times 10 is 20. This one here would be 2 times 10 squared, which will be 200. Okay, and again 2 times 10 cubed, which would be 1000, and so on all the way up. Just note that a sequence is a list of numbers with the commas between them, and a series, don't forget, is we'd remove the commas and now put addition signs, because with a series we're going to sum. The nth term is given by Tn equals A times R to the power of n minus 1, and the sum of n terms is given by Sn is A to the R to the power of n minus 1 on R minus 1 for R greater than 1. If you have R between -1 and between 1 and -1, so less than 1 and greater than -1, then you can use A times 1 minus R to the n on 1 minus R. Okay, now an infinite geometric series, if n approaches infinity here, if you notice here, if n approaches infinity, what we're left with is that Rn approaches 0. Okay, in the case where we have R less than 1, greater than -1, then Rn approaches infinity, and so we have S infinity is equal to A on 1 minus R. Okay, because if this R is less than 1, okay, then the larger we go, the smaller it gets, and it heads off to 0 as n approaches infinity. And so in the limit we have A over 1 minus R. Let's have a look at an example. Here's a sequence: 1, 3, 9, 27. Okay, find the 10th term, T10. So A is 1. R, the common ratio, is T2 divided T1 or T3 divided T2. It's any two terms next to each other, the latter of the two divided by the former. That gives a common ratio of 3 here, so it's going up by a factor of 3. Tn is AR to the n minus 1, so T10 will be 1 times 3 to the power of 10 minus 1, and that will give us 1 times 3 to the power of 9, which is 19,683. We want to find the sum of the first 20 terms, S20. Sn will be A times R to the n minus 1 on R minus 1, so S20 will be 1 times, in parentheses, 3 to the power of 20 minus 1 on 3 minus 1, and again gives us this very, very large number here. And what have we got here? Okay, about 1.7 billion. All right, a bit over that. Let's have a look at this sequence here: 4, 3, 9 on 4, 27 on 16, 81 on 64. Okay, find the sum to infinity. If this series continued on and contained an infinite number of terms, what would its sum approach? What would the sum of those infinite number of terms be? A is 4, R is 3 on 4, or 0.75. S infinity is A on 1 minus R is 4 on 1 minus 0.75 to give us 16. In the limit, as the number of terms goes to infinity, the sum is 16. Alright, that's it then. Don't forget, the difference between a sequence is that the sequence lists the numbers with commas between them. A series lists the same numbers but with addition sign between them because you're summing them.